Good afternoon, everybody. Can you hear me? Great. My name is Oscar Melo. I am a professor at Catholic University in Chile, and I'm part of the board of LAERE. And it is a great honor and privilege to welcome you all to this Congress, our first Congress of the Latin American Association of Environmental and Resource Economics. I have to say, though, that this is not our first attempt to have an association like this, and some of you that have been around for a while know that this is probably like our third attempt to have an association, and I'm really confident that this time we're going to make it. Today I have the pleasure of introducing one of our keynote speakers, a scholar whose work has significantly shaped our field. This is Professor Ben Groom, who holds the Dragon Capital Chair in Biodiversity Economics at the University of Exeter Business School, and has been at the forefront of research on topics that are fundamental to our discussions that we're having today. His work explores critical issues such as social discounting, intergenerational equity, natural capital valuation, policy design for sustainable resource management, which address not only theoretical questions, but also offer practical tools for shaping policies that can affect the future of our natural environment. His contributions have been influential in governments, international organizations, and policy debates around the world. From the evaluation of biodiversity and ecosystem services to the economic frameworks that guide climate action, his insights help bridge the gap between rigorous academic research and the real-world decision-making. As Latin America stands at the crossroads of economic development and environmental conservation, Professor Groom's work offers invaluable lessons on how we can navigate this balance, ensuring that prosperity will safeguard and offer a natural bridge to meet this challenge. Please join me in welcoming our esteemed keynote speaker, Professor Ben Groom.
Muchísimas gracias por la invitación aquí. Estoy muy feliz que puedo estar aquí con ustedes y al principio del nuevo Congreso de los Economistas del Medio Ambiente en Latinoamérica. Es un gran honor. That's about as far as my Spanish goes, so I am now going to move on. I'll move on to the talk. Thank you very much for the introduction. That was I almost didn't recognize myself. It was an incredible introduction. Thank you very much for being so thoughtful. Right, today I'm going to talk about valuing nature-based solutions for climate change and pricing biodiversity. Some nuts and bolts, basically. So there's going to be some details here about why nature-based solutions are particularly valuable, and then how we're going to a proposal really for how we can value biodiversity as part of that. So as some background to all of this, I'm going to explore the space a bit here. This is the kind of background that I had in mind here. So I think a lot about forests in this context of nature-based solutions and its connection with climate change. Of course, you could think about other nature-based solutions in marine environments and so forth, but my head is really usually thinking about deforestation. And like since 2001, an area of the size of Germany, France, and Spain put together has been deforested. All right, across the globe. And forest losses and climate is really closely related to climate change, so emissions contribute about 20% of emissions of carbon dioxide every year, and of course, closely related to biodiversity loss. And we're seeing estimates vary, right, widely. And we're seeing sort of extinction rates between 10 and 100 times higher than the background rate of extinction as a consequence of human action here, right? Okay. Then we have the Descriptor Review, a major report on the economics of biodiversity that was funded by the UK Treasury. And the key message of that is that this sort of cannot go on, that the economy is embedded in the environment, and at some point, as environment dissipates, that affects all economic activities. Yeah? So not only does the economy affect the environment, but it happens the other way around, and we really are, they're complementary to one another. So the economy is embedded in nature, right? So in that context, nature-based solutions for climate change offer something kind of quite potentially very important. You know, they could be low cost, right? Thinking about forests, they can be low cost in principle. And of course, they hit the biodiversity scores. They can do well on biodiversity front as well, okay? So the problem, though, has been in recent years, actually, is that the kind of attempts to bring nature-based solutions in the forest sector to bear through REDD+ or VCM, the voluntary carbon market, or protected areas and so on, there's been a crisis in terms of additionality. Right? So we have really low additionality, and here's a report, the classic report that we saw a couple of years ago. You know, 61% of value drops as a consequence of this additionality crisis, which basically said that we're talking really about the voluntary carbon market here, but I could be thinking about other policy failures as well. 90% of voluntary carbon credits were non-additional, right? So in that context, we need to think about. I mean, here's the results from the kind of famous science paper from West et al. You know, they did kind of causal inference, synthetic control, and this is Peru and Colombia and all the countries in Africa are lumped together for data reasons there. But you know, nothing is happening in terms of the average treatment effect of these carbon credits. Okay. In REDD+, we had this paper in PNAS a while back, and that basically said, yeah, there was some kind of effect of the moratorium on palm oil that took place in 2010. But actually, when you look at it, it's only 2% of the nationally defined contribution. So a little bit additional, but really, in terms of magnitude, not enough, right? Okay. So here's the three things I want to say that can hopefully bring back nature-based solutions. And I think these are kind of necessary, though they won't be sufficient. They're necessary things that we need to think about in order to bring back nature-based solutions. First thing is temporary emissions reductions. You know, even though nature-based solutions can be risky and impermanent, they can be valuable, right? Secondly, we need to somehow price biodiversity into nature-based solutions so we can at least say something about the quality of the provision out there, and then probably retrieve more in terms of finance there. And then lastly, we need to address the question, broadly speaking, of additionality, right? So those are the three things I'm going to look at. So let's get cracking. Social value of temporary removals of climate change. A couple of years ago, Frank Vemmans and I had a paper out in Nature, and basically the question it's trying to ask was, do temporary emissions reductions have any value whatsoever? You know, the main argument against the VCM was that these kind of offsets that were being produced were impermanent, highly risky, non-additional. Okay. Is that enough for them to be valueless was our question. All right, so let's get at the start of this and think about what the value of carbon removal actually is. So here's a graph of a pulse of carbon, right? At the top there, you've got what happens to concentrations. So immediately spike up and then gradually, you know, dissipate in the atmosphere over time, right? On the bottom, you've got temperature. What happens to temperature, right? And because of various things, mainly including the kind of saturation of carbon sinks, the temperature effect is basically permanent, right? So how do we value this? And this is an important equation here, that temperature change is linearly related to the stock S of carbon emissions in the atmosphere, all right? So that's going to come back. Remember that equation if you can. That's going to come back at some point. Social cost of carbon, right, which would be like the tax we would put on carbon or the price that we ought to be paying, is basically you can imagine attaching a marginal damage to each time period to this temperature change, and summing it up over time, over an infinite horizon, in present value terms. That's the social cost of carbon. It's the present value of all damages into the infinite future, right? So it's an asset price, basically, right? Okay, so that's a permanent emission, right? That's the value of that. What happens when you have a temporary emissions reduction? So using the same kind of models here, what happens, right? So you can see that in the first instance, we get this immediate drop in temperatures as a consequence of the removal of carbon dioxide from the atmosphere, right? That lasts in this instance for like 50 years, and then it's re-emitted, and temperatures return basically to where they were. These are all the kind of CIMP models, different combinations of energy balance and carbon balance models. The yellow one is the one that really is used typically as a kind of summary of all these models. It's the FAIR model. Okay, so does this have any value? Well, in fact, what we argued basically in the paper was that, yeah, it does. You can just kind of attach the reduction in damages to each period of time, and the integral there goes from T1 to tau 1 to tau 2, which is basically the duration of the emissions reduction. And so you just sum up and you've got the marginal damages in this step of temperature reductions from a temporary emissions reduction, okay? So that's your integral under there of damages. It's a bit like the social cost of carbon. We called it the social value of an offset. It's a bit like saying, look, here's to begin with, you gain the social cost of carbon. That's your benefit in the first instance. And then when things get emitted, you have to take away the damage that you caused from the social cost of carbon at time T2, right? That's valuable, right? That is a valuable thing. It's a change in temperature, and higher temperatures are damaging. This is valuable. Okay, so you can write this down very simply. Social value of offsets, let's call it, is a kind of a discounted version of the social cost of carbon, right? Which reflects the delay, reflects the impermanence. And then if you think about the risk of a failure of a project, like a forest project, you can add in a failure risk component, and you can add in an additionality risk component. You know, what happens to this project compared to the baseline? You know, how likely is it to be additional? And you've got an asset pricing formula there for a temporary emissions reduction, okay? It depends on some macro characteristics, you know, discount rate, and how X is how the social cost of carbon changes over time. That's dependent on growth and things like that. And you've got some project level characteristics. How risky is this project? How likely is it to be additional? These are like hazard rate type metrics, okay? All right, so valuable. And you can then sort of do an equivalence type calculation and see, like if you look at on the left-hand side here, all the kind of hazard rates associated with these different papers that you see in the literature. Jayachandran, they were quite additional, so there was hardly any risk there in that paper. If you go to the West et al. Paper, the 2023, that's a 4.6% hazard rate. That basically means that sort of a 25-year, I'm just going to switch everything off, or I'm going to try it. No, okay. Anyway, I'm going to walk over. I can do that. 4.6% for 25 years. That's only 13% of a permanent reduction in carbon emissions. Okay, so additionality really, really counts and reduces the value of the reduced carbon emissions. Right? If you add those things together, then obviously it gets even worse. Right? So you can at least price in, even if they're risky and impermanent and have different problems in terms of additionality, things still have value, right? We shouldn't be throwing the baby out with the bathwater is the kind of broad argument here. Okay. All right. We can take this further. Tipping points, right? So imagine, yeah, there's your temperature as a linear function of stock of carbon. Here's a change in temperature is basically what you get from the emissions reduction of a project. Here's the probability that a tipping point has happened at any given temperature, right? And here's the change in temperature, change in the probability of your tipping point happening, right? So from this, you can basically get the change in the probability of a tipping point happening based on the emissions that you get from a project. And there are two values that you get from this. Firstly, if your project happens before the peak temperature, then you don't avoid the tipping point, but you do delay it somewhat. So there's a delay value of coming from a temporary project, right? If your project straddles and kind of shaves off the peak temperatures, you also get the possibility that you avoid the tipping point from this temporary project, okay? So again, some values that come from temporary, possibly risky projects, right, in nature-based solutions. Okay? So just thinking kind of theoretically about it, again, there are various values that we could ascribe to nature-based solutions. Okay? Right, these equations, you don't have to understand them, they're there just to make it look like we did something serious here. Okay? All right, so tipping points. There are other tipping points as well, just two other things. You know, that was based on the level of the temperature. It could be that the duration at which you're at a particular temperature determines the tipping point. That's like with Arctic ice melt and so on. It depends how long you've been at a particular temperature. It could be the speed of temperature increase, right? You know, like adaptation depends on, your ability to adapt depends on the speed at which temperatures are changing, right? And of course, you know, like think about ecosystems adapting to new temperatures. If that happens very quickly, they're not going to do that. So again, in the paper, we show that these are two other values. In fact, they're even more value. You know, slowing things down, reducing the duration. Temporary projects could be really handy here, all right? We could, here's another idea, very quickly. We could repurpose temporary emissions reductions. Like methane, if you have an emission of methane, that's the blue pulse there, it's a very quick and powerful effect on temperature, but it dissipates very quickly, so it's quite temporary, right? Well, you could repurpose temporary projects to kind of immediately offset those temperature changes, right? That has a number of advantages. You can contract over shorter periods and things like that. But, you know, you could repurpose them for methane, for instance, if you wanted. Okay. It's expensive, though. 136 offsets are required to do that, okay? All right, so there's some value in some of those kind of risky, you know, and it depends on how risky and so on as to whether or not they're going to be cost effective, but we shouldn't be throwing the baby out of the bathwater just because there's some risk involved in nature-based solutions. Okay. All right. Here's valuing biodiversity. Check this out. This is difficult, right? But I think we're in a heyday of biodiversity valuation right now, and I'm going to take you through a couple of examples, right? Okay. And then I'm going to propose a way of pricing in biodiversity. So we've seen. So here's a test, right? Frank and Sudarshan, who hands up in the room, who has read this paper? Okay, that's actually good, because I can just talk about it for a bit then. But it's an incredible paper, right, which is trying to say something about how connected we are, how connected our economy and our well-being is to you know, species, biodiversity, and so on. In particular, it's talking about keystone species. So this is the story. A patent lapsed on a painkiller called diclofenac. That was used in India on cattle. As soon as the patent went, people started using it a lot on cattle because it improves the productivity in milk production. And it turns out this is highly toxic to vultures, right? And so what happened was vultures died in huge numbers in India, right? Then what happened, and this is well known in the ecological circles, right? But wasn't well known was like the connection between that well-observed incident and public health, right? So what you had was, via various kind of vectors here, you know, dogs and rats taking over the job of the vultures. Now, the vultures, what they used to do is dispose of cow carcasses that died out in the wild and so on. And they used to do that extremely well, like waste disposal machines, 40 minutes, all meat gone, just bones, right? When the vultures disappeared, the dogs and rats and so on started taking up. They know this because they collect data on such things in India, can you believe? Took over that particular niche, but they're nowhere near as good at dealing with all of that waste stuff, right? So diseases spread. This had impacts on child mortality. And in the end, it's incredible that there were like 0.48 more deaths per 1,000 as a consequence of the loss of vultures. This is 104,000 deaths, value of statistical life, $665,000. That's a loss of like $70 billion per annum, right? Incredible. Incredible study, right? Incredible study. I recommend those who haven't read it and to read it, and those who've read it before, read it again. It's quite good. Okay, this is another amazing story about bats. What happened there was there's a disease called the white nose syndrome, which kills, like if it's in a colony of bats, 90% of them are more or less guaranteed to die. All right? So what happened there? Bats do a lot. They eat a lot of insects. They eat something like 50% of their body weight every time they go out in insects. Yeah, so they have this incredible sort of pest control ecosystem service that they provide, right? It's absolutely amazing. So when they died in these particular areas in the USA, what happened? Well, farmers knew this very well. They saw their crops basically becoming less productive. They used more pesticides. So that cost them a lot of money in terms of lost rents. But then also, in Frank's science paper, he shows that this also had an impact on infant mortality and such like in the US, right? So water quality effects had a human well-being outcome, you know. Incredible story, right? So agricultural losses, 27 billion, infant health, 10 billion. You know, this is a significant proportion of the GDP coming from agriculture in those particular areas in the US. Amazing story, right? Incredible, like a brilliant vignette to tell us something is going wrong here, and illustrate the connection between economic activity and biodiversity. Okay, check this story out. This is really interesting as well. Biodiversity is often said to have an insurance kind of property. So the more diverse a system is, the more resilient it is, the more it handles shocks to weather or whatever it is, right? So this study is from a friend of mine called Stefan Baumgartner, who's an ecological economist. The paper's not out yet, but he sent me his slides and I copied them onto my presentation. It's all about pollination of almonds in California, right? So biodiversity here is V. You've got different types of pollinators, honeybees, wild bee species, flies, and other pollinators, and so on. Now, what happened was the teams of people, this is amazing, right? The teams of people in orchards in California, biologists, counted up the bugs that were on the flowers in the springtime of all the almond trees in this particular orchard. And then they came back later to see how that affected, whether it was related to productivity of the trees, right? So this is what they found in the end. So the yields vary, right? Of course, it's quite random and stuff, but as you move to the right here, more and more green, you're getting higher yields of almonds as a consequence of additional pollinators here. But you've also got this kind of effect on the distribution, which is narrowing the kind of variance as well a little bit. Okay, so you can see, like, and basically what's going on here is that the biodiversity part is determining the lottery of your yields here, effectively, the mean and the variance of it. Right. So anyway, you can see the outcomes there: changes in the standard deviation and the contingent, coefficient of variation declining as you get higher numbers of pollinators there. Okay, so that's a pretty incredible story, right? There are lots of other values as well of biodiversity, which Partha Dasgupta in the Dasgupta review refers to kind of invisible biodiversity values for two reasons. One, they're never priced in by these biodiversity values, and some of them you literally you don't see them. But here's a kind of list. There's all the kind of ecosystem services, of course, provisioning, regulating, cultural, supporting ecosystem services, all that kind of thing. There's bioprospecting, perhaps. You know, we get, like in the Dasgupta review, it says that 90% of cancer cures in the 90s were coming from like bacteria and fungus varieties in soil. You know, stuff you really don't see, but is hugely valuable to us, right? Existent values, yes. Carbon values, of course, a really nice paper by Erin Sills there in Nature Ecology. And, what's the name of that journal? It's not Econ, I don't think. Evolution, that's what it is. Yeah, sorry about that. And then, of course, you've got resilience stories as well. So here's the kind of, this has been very well researched by people like Karlgård and Melo and Ann-Sophie Crepin. This is the kind of shallow lakes in Sweden, right? You know, you need to manage the biodiversity here in order to stop them flipping over into some kind of other irreversible state, right? So tipping points and resilience are really important functions that biodiversity plays. Okay, so we know this is, there are lots of interesting studies here. We're kind of getting a picture of how valuable biodiversity is and so on. And so there's kind of micro little studies here. So on the macro side, there's sort of various studies which have been undertaken over the past. This is very difficult to put together, so usually it's just all conceptual stuff. But a recent paper by Giglio et al. Takes this kind of view, and it's very useful for making a particular point here about, which leads into my proposal for pricing, okay? So they view the economy and the relationship with biodiversity and species as follows. And it's sort of interesting, right? I don't say it's the be-all and end-all, but it's a really interesting process. So your aggregate production there, a function of just general economic inputs and ecosystem services, right? Ecosystem services, 1 through to big G, feed into individual ecosystem services. So you've got climate regulation there, water quality, you've got soil retention, you've got all sorts of different ecosystem services feeding into aggregate production and the well-being of the economy, right? Then each of these ecosystem services depends on species number. So you've got species 1 through to G, and they have different populations, so you've got varieties of species there, okay? They model it as follows, right? So ecosystem functions depend on species. And then they say, right, these sets of ecosystem services are complementary to one another. So they're building in, actually, the Dasgupta embeddedness idea. So complementary things, if you lose one of them, everything disappears. It's like an O-ring type problem. So that's one thing, complementarity of ecosystem services. Second thing is species substitutes, right? Within a given ecosystem service function, you've got species which actually, some of them, if you lose one species, another one takes over and does its job, right? So they're substitutable. So this introduces the idea of species redundancy and the idea that, well, basically, you'll see if you've got species along the bottom there and ecosystem services on the y-axis here, you'll have some relationship that reflects the redundancy of species. So if you lose species to begin with, you don't really see anything changing in your ecosystem services, and then suddenly it drops off. You've got, in a kind of tipping point sort of way. So that's sort of trying to say that by observing, even if we are doing these amazing empirical studies, we're not going to observe much relationship between species numbers, species richness, and ecosystem services, and hence the connection with the economy. What A.L. Frank and the Keystone Species studies were doing was looking at this last bit here, this bit where everything becomes a keystone species, right? Suddenly there's no substitutes and everything is a keystone species, and then you lose production rapidly, right? Okay, so we have this sense that it's very valuable biodiversity, and but we need some way in which we can price this in, given that valuing biodiversity is such a tricky thing to do. You know, we can't all spend the summers counting insects in an almond orchard, right? We need some way to deal with this so we can have a price that guides our decisions with relation to biodiversity and then nature-based solutions and so forth. All right, here's my proposal. You might not like it, I warn you. All right, here we go. So this is what we do with carbon in the UK. Instead of estimating the social cost of carbon and having endless protracted debates about the discount rate and the damage function and all of that, what we do is we say we've got a target and we see how much it costs to reach that target. And then the price that we use for carbon is the marginal abatement cost, okay? So you've got a target, you see how much it costs to reach that target. The shadow price is right at the margin there, okay? It's the price of that constraint, the shadow price of that constraint. So my proposal, and this is what the prices look like in the UK, and that's what we do, right? We have a target, marginal abatement cost. My proposal is let's do the same for biodiversity, right? Let's say we have a target for biodiversity, and that target can embody all of those values that we had before that I've just shown you, and perhaps be precautious about species loss and so forth. And then we see how much it costs to reach that target. Then we have a shadow price for biodiversity. Okay? All right. So here we go. This is how we're going to do it. I think the right target is about extinction risk. You might have some other thing that you're interested in, and if you do, then knock yourself out. You can go and do this exercise using that particular metric. I think it's extinction risk is the most important thing, and many others do too. Fortunately, we have some ecological theory which tells us how extinction risk varies with some important policy variables, which is land use. Okay, so here's the extinction risk is equal to 1 minus persistence, where persistence is determined by current area of habitat for species I divided by original area of habitat. So it's like what's remaining of the habitat for this particular species raised to a power z, right? So we have this ecological relationship that we can use. We can now say, okay, how much does it cost to change land uses and influence extinction risk? So how much does it cost to meet our extinction risk target? Okay? Okay. So that's the definition. C is current area, O is original area, Z is a parameter, right? And you can imagine this is what it looks like. Persistence is related to proportion of habitat remaining in this kind of way, okay? And then you can build up an index for any area of land that you're thinking about, which just layers up all of the extinction risks associated with the species in that area and takes the average, okay? All right. So that's what we're doing. And then you can find out the marginal effect of changing that land from current habitat to original habitat and what its effect on extinction risk is. Okay? So that's our marginal benefit, is our change in extinction risk as a result of restoring a particular piece of land. Okay, so we did this. Oh yeah, and then once you've done that, you can rank areas on the basis of their cost effectiveness. You can take the marginal benefit in terms of extinction risk, divide that by the cost of buying the land and restoring the land, and then rank your land area on the basis of that. Okay? All right. This is what we're calling the target and cost-based approach, and this is what we did. We did an example for Europe, right? So what we did was we had a cost layer. This is opportunity costs of land in Europe, right? All the EEA areas. We have a habitat layer, so we have like current area of habitat, and then we have like an original one. Imagine if it all went back to how it was before, sort of thing. Yeah. So we imagine switching from one to the other. Then we have we know which species are in these areas because we know the range maps for all different species. So for any different grid square that we're looking at, we know all the species that would respond to a change in habitat in that area, right? And we can calculate the extinction risk change as a consequence of that. So we did this for Europe, and this is what we ended up with. This is our marginal benefit, remember, which is the change in extinction risk as a result of this land use change, restoration of habitat. We ranked it in terms of cost effectiveness, and this is what our map looked like. So the red areas, this is a bit larger, the high priority areas. These are the areas you would target if you wanted to attack and reduce extinction risk. Mediterranean, Iberian Peninsula, and for some random reason, Gotland, up near Sweden, right? There's some mammal there which responds very strongly to changes in habitat, and it's also quite rare at the moment, right? So anyhow, so there. But just an illustration, really. The Mediterranean also has cheap land and also highly diverse, so that's your priority. Okay, that gives you an abatement cost curve, right? So you start with the red areas, and then you move up, and you've got this, exactly how much it's going to cost to improve your persistence score, which is along the bottom there, and reduce extinction risk, right? So it's very nuts and bolts, this. I'm sure you'll agree, okay? So that's your marginal restoration cost. And then if you flip that over, you get what's like the cost of a statistical species. It's the cost per change in extinction risk. And because we're dealing with risk, it's a bit like a value of statistical life. It's a cost of a statistical species, okay? So that's what we did for Europe. And now what we can do is say, okay, any target that we want to hit for persistence or extinction risk, we just plot it on that graph, and we know we can read off what the shadow price is for biodiversity. So we have a pricing strategy here, okay? So how does that work? How does that work in the end? So this is how we would do this in practice. It's a real kind of nuts and bolts cost-benefit analysis exercise. See that square there? That is a project, right? It's a forestry project, which we're imagining changes from original state to a kind of forestry enterprise, okay? And we want to know what the cost of that is in terms of biodiversity, in terms of our extinction risk. So we can basically price the biodiversity here for using our method, and we would do the following thing. We'd say, look, imagine our target is 0.9 for our persistence. Yeah, that leads to a value of a cost of a statistical species of 4 trillion. The project has an effect of minus 0.0001 on extinction risk. You multiply those two things together, the cost of that project in terms of biodiversity is 41 million euros. Okay? So you've got a way in which you can kind of prioritize now in terms of biodiversity, but also just in terms of your overall priorities as a government as well. All right. Guess what? We did this for Colombia as well. So for the Andean region. So this might be a bit objectionable, but let's see how this goes. It's very rough and ready, right? So here we go. We looked at the Andean region of Colombia here, this particular region here, and mainly for data purposes. Here we have our habitat types, right? Here we have our cost layer. Someone did a really brilliant paper on land use costs for Colombia, by the way, using machine learning. Amazing. So we use these data. Here's the spider monkey, for instance, like that's current area of habitat and an original area of habitat. So we can see what happens if we change one, restore a particular area for this particular species. But we have all sorts of different species for Colombia because the range maps are pretty amazing. Obviously, it's a highly diverse country. So we did that, and then our prioritization on the basis of that are these three different areas in the Andean region, right? So Magdalena River Valley, just in that particular portion there. I think this is right. I did this very last minute, so if my geography is all wrong, please shout out. But the Cordillera Oriental branch right over there, the eastern part, and Nudo de los Pastos. I mean, I don't know these places at all. Hopefully they mean something to somebody, but this is where you would start, is basically what I'm saying here, yeah? Okay, now, of course, the costs here are just like opportunity costs. And if you're going to do this properly, of course, you would be very careful to be talking to, people on the ground, indigenous communities, and having a discussion about what the overall strategy is. Of course you would. Okay. And for Colombia, if you had a 0.96 for target for persistence, then your value of a statistical species is basically $50 billion. And then you can use that for cost-benefit analysis of any intervention in Colombia that has an effect on biodiversity. You can price it in using that shadow price, okay? So that's the idea, all right? That's the idea of how we can price in biodiversity to nature-based solutions or indeed government decision-making or indeed anybody else's decision-making with regard to that affects biodiversity. It circumvents all of those difficulties of valuing stuff. I think those are important things. The fact that we know all of those values are more or less exist, that tells us something about where we should put our target, how stringent that should be, right? Those are super useful studies, and while we're waiting to get a complete picture of the value of biodiversity and how it affects our lives, sometimes in surprising ways, maybe we should do a cost-based approach and say, look, we have a target, let's do this, okay? All right, last thing is additionality. So I'm going to overrun by a couple of minutes, unfortunately, but here we go. So additionality, none of this works if we don't have additionality. You can throw money at things. If it's not additional, then nothing changes, right? So I want to kind of define additionality. It's important to do this. We do it in this kind of counterfactual context. So imagine this is your trend in a pre-project, then post-project. Different things are possible. You can have different types of additionality. Potential additionality is the green bit here. It means that this is what you could achieve if everything goes perfectly well, right? Then, of course, you've got realized additionality, which is kind of actually what happens in the end. And then this is all compared to a counterfactual world, what would have happened anyway, right? So additionality is what happens in this particular project or policy compared to what would have happened anyway, all right? And this has been a bone of contention in the VCM story, the voluntary carbon market story. And those people who wrote that paper got a lot of pushback on the basis of their definition and use of synthetic control to determine the additionality of those carbon credits. Anyhow, I think that's something which we should agree is a way forward. We should agree on some very robust methods to determine additionality. And there should be, in another paper with Philippe Delacote, we argue for a body which does this. Okay, this leads to the idea of sort of potential additionality, I think, as being looking at risk of deforestation. So the places where you have high risks of deforestation, those are exactly the places where you would get most potential additionality, you know? You'd stop that risk from manifesting. Okay, and that kind of idea, you see it in a lot of other pieces of work. So this is from Alex Garcia. I mean, I could have chosen many different papers from Alex Garcia, from Kate Sims, from Erin Sills, from all of these amazing academics who are doing lots of really detailed work, which I'm just in awe of. But I thought this kind of representation from their 2015 paper was really interesting. So on the x-axis here, you've got some measure of quality of land. It could be slope, right? The slope of the land. And these lines here is the steep ones are kind of agricultural rents, and the less steep ones are kind of forestry rents, right? So as the slope increases of the land, that really affects agricultural rents dramatically, until at some point it becomes, at this point over here, it becomes more profitable to work in forest, to have forest production instead of agriculture, right? Okay. So then if you're targeting some intervention of like, who should you pay, this is a PES context here, who should you pay to reduce deforestation and so on, it's really important that you know, if you do broad targeting, here, where you have like very high slopes, then a lot of the payments that you present, if you pay this much in terms of PES, they're kind of inframarginal and they don't actually change anyone's behavior. In fact, if agricultural rents increase, the only people who change their behavior from that policy would be here, right? Very small change as a consequence of some PES payments. And this framework, they argue, explains a lot of the some of the results they get from their analysis of this payments for ecosystem services project in Mexico. Some effect on forest cover, very small effect on poverty and such like. But it sort of what they argue is that actually what you should be doing is targeting where there's very high risk, where it's actually high, right at that margin there, where people are going to change their decisions, right? So it's really important that you end up focusing in on those high-risk areas where people can make their decisions. And in fact, higher payments would get rid of, they argue, so if you have agricultural production becoming more productive like this, and then you have payments like this, you end up avoiding all of that deforestation that's happened as a consequence of agricultural improvements in productivity. So, really important point, the risky areas are really important to focus in on if you want to have additionality, all right? So that's what we've been doing in a project that we have with some of the people in the audience here, Sarah Meyer, Ville Inkinen, funded by the UK government. We've been looking at kind of risk in Latin America, where the risks of deforestation are, and then sort of thinking about where we should be targeting for additionality. For the sake of time, I just want to mention this amazing paper that if you haven't read, you should read it. Aston Sal's paper in Restud. They show how you can really improve targeting once you've done a brilliant job of estimating the full gamut, full distribution of impacts of different policies. This is the blacklisting policy here. But what I wanted to really show you is what we've been doing in this project with Ville Inkinen and a bunch of people at Exeter University and the LSE. We've done a machine learning exercise where we've just used economic and geographical data to predict the risk of deforestation in particular areas in South America, right? So what the machine, with the idea of looking at potential additionality is like the risk of deforestation times the forest density. And that's where you get the biggest kind of potential additionality. So you look at these areas here that it kind of focuses in on, these lighter areas, and they are clearly highly active areas of agriculture in different parts of South America. So these are the areas which have high potential additionality in the end, okay? Remember this, you can turn that, this is the social value of offsets, the carbon value of risky risky potential nature-based solutions, you can turn that map into a map of the value in terms of carbon associated with these different risky areas. And you can look at it from the perspective of primary forest, reforestation, and protecting secondary forests, right? So the lighter areas in Bolivia are the ones which have the highest value of, potential value of additional carbon as well. Okay, so just using those ideas of risk and so on as being highly important for determining where you get additional benefits from different projects, we're giving a sense of how we can plan and target different areas to ensure additionality for nature-based solutions. The last bit is, and this is a paper that Ville Inkinen will present tomorrow, I think, in one of the sessions. It's about protected areas. What we did was we did this kind of analysis of deforestation in Bolivia, coupled with the coming in and out of different protected areas, and we try and work out whether they have been additional. But we do that by matching on risk of deforestation, right? And if you want to find out the answer to this paper, then I recommend you go and see Ville present it tomorrow, right? But I think you know the answer already, right? In terms of what I've said about additionality and risk going hand in hand. Okay, summing up, slightly overrun, but I hope it was worth it. 3 issues for nature-based solutions. Nature-based solutions important, even if they're risky and impermanent. We can measure the quality of these different nature-based solutions if we think about things rationally, and it's very helpful to have a bit of economic theory to do that, right? Biodiversity, difficult to value. We know those vignettes of vultures and bats and so forth are so incredibly powerful. I think they are going to drive the policy along a little bit, but if we really want to have some nuts and bolts pricing going on, we can do that with a cost-based approach, I think. And then finally, additionality is key to all of this. Risk targeting, the trade-offs between, incomes and effectiveness on the environmental side, and above all, transparency are key to making nature-based solutions workable as we go on. Thank you very much for your attention. I'm happy, I can take questions. Yes, happy to do that.
Yes, thank you for the presentation. It was wonderful. I have a question. When I drew marginal abatement costs for the case of carbon, I got this statement that we may be locked in some technologies and actually not reaching net zero, because when you decide on whether to abate based on marginal abatements, have you heard something about that in the case of biodiversity? Meaning, for example, that some highly valued species are in very expensive lands, like those types of correlations?
Okay.
The question is whether, have you received any critiques?
Have I received any critiques? Okay.
Like that.
So, plenty, yes. Obviously, it's a gloves-off approach to pricing biodiversity. People feel very strongly about biodiversity and the fact that, the key thing here is that with carbon, you have this very clean measure of what you're trying to achieve here. Ultimately, it's the temperatures, but you measure it in terms of carbon emissions, right? With biodiversity, what I've done here is basically say that extinction risk is our measure, is our carbon emissions here. Yeah, and that's fungible no matter, it doesn't matter where extinction risk gets reduced or increased or whatever, it's the same thing and it's comparable, so it's fungible, right? That, of course, is problematic, yeah? Because if you preserve one species in one area and not in another, those are different species, and how fungible really are they? That's a big question. But I think that we need to measure this. Right? We need to, in any event we need, if we have targets, which we do under the Kunming Montreal Protocol, is it a protocol? No, it's an agreement, isn't it? We have targets for reduce, like 30 by 30, for instance, but also reducing extinction risk tenfold is one of the targets there, which was recently agreed again at Cali and all of that, right? So we do need a strategy, right, to meet those targets on extinction risk. And from that comes implied shadow price for thinking about other interventions in society, right? So I'm not necessarily apologetic about being sort of painting over or glossing over the fact that I've assumed fungibility in terms of extinction risk here. So that is the major critique I would often get, and there are probably some others which you were hinting at there, which yeah, I think that's my answer to that question. Yeah.
Thank you, Ben, for a great presentation.
Thank you.
My question has to do with when you show the maps of priorities, for example, the one for Europe with Spain and Mediterranean countries.
Yeah.
And then you showed that you seem to hint that the location of the places where to start is to a large degree determined by the fact that land is cheap or cheaper in those areas.
Yeah.
And I wonder, what is that relation to that, between that statement and your concern with additionality? Because it could be that those areas were not going to be affected anyway. That's what because their value in agriculture is low or in housing is low, and therefore they were not going to be, let's say, there's going to be no land use change there anyway. How do you make these two compatible?
So this is what you're talking about
exactly.
here. Yeah. So the first point, it's a combination of like. So if I were to do this map again, but I would just go for the cheapest land possible, right, irrespective of the extinction risk that I could obtain in every little parcel of land, the whole of Norway would be red, and we would start there. Yeah, that would be if we were just thinking about cost minimization, but we're not. We're thinking about the bang for the buck. We're thinking about marginal benefit over cost of land, right? So it's a combination in the Iberian Peninsula of some areas of cheap land, but actually some areas of really important reductions in extinction risk. Okay, so it's a bit of a mishmash of different things. If you were to do it just on the basis of marginal benefit and not think about costs, it looks a little bit similar, right? So that's one point. On the additionality side, I don't know how to answer that. You might have caught me out there, actually. I'm not quite sure how to handle that. I hadn't oddly considered it. But what we're doing is we are looking at agricultural land and moving that from current state, which is under production, to restored state. So that, in a sense, is additional because it wouldn't have happened otherwise, right? But then I think the next kind of subsequent question is who has the power to do, this is like a planning exercise here, which has not involved any people on the ground. I think that's a valid next point. So all that means is that the abatement cost curve would then have to include all of these kind of political economy type costs and other such things through negotiation, right? So yeah, starting point. Yes, other things that need to be considered. Also, by the way, one should consider contiguity of land and also wider ecosystem benefits, not just extinction risks, right? So, yeah. Great question. Thank you. Any more? There's one at the back.
Yes, you see it, yes. One question. So thinking on a payments mechanism, right? And looking at your map, we will never expect to have Spanish firms buying credits in terms of biodiversity, offsetting, or kind of a thing like that, because that's the most cost-effective area. So in Spain, Spanish firms will never will buy those kind of credits if something like that is created, right? Because they need to protect, right? I mean, they need to protect those areas. I don't know if I'm clear.
I'm not sure. That sounded like a statement.
So
About Spain.
my question is how thinking on an offsetting mechanism, for example, if there is something like that for biodiversity, how would that work for areas or firms that would like to buy those kind of credits in areas where they are highly cost effective?
Yeah.
Would that make sense? Or
Yeah, so absolutely. I get it. So I haven't really thought, this is much more of a kind of stepping back and here's a strategy and this is what the shadow price would be. But I think once you have that strategy in place, any kind of credit that people want to contribute to, you can give it a quality measure on the basis of this shadow price or on the basis of this cost effectiveness type analysis, right? So that's sort of what's lacking in a way in terms of the failure of the voluntary carbon market is that nobody knew what the quality was of the different credits that they were buying, and that turned into a kind of market for lemons. I in my head, that's what happened, and so the valuation of temporary emissions reductions and this kind of approach in terms of valuing biodiversity, I think, can then contribute a kind of quality measure. Of course, this is not the only thing that you need to solve the inadequacies of some of these market structures, but I think it's an important starting point for being more discerning about the quality of the credits and how exchangeable they are. Yeah. I can't say anything about what will and will not happen in Spain, by the way.
Yeah. Hi. Thank you. Very good presentation. Thank you. Here in the very back. Yes.
There's somebody. Oh, sorry. There you are. Yeah, I'm staring over here. There's so many lights. I don't know who's saying what. So, yeah.
So thank you. So I was wondering whether your work has some conversation or something to say about urban versus rural context, or do you have a scope within rural, semi-rural context, and then there is all this biodiversity that you are not valuing that will also be relevant in urban context, where species are already gone, right? They are not there, but they should be providing some services that we should value.
Yeah. So I think if I understood well, there's two points to that. There's one is that you've got incredibly degraded areas which take a long time to come back into any kind of suitable habitat for species, and that is somewhat taken into account. We have a suitability layer here, but there's no time here, right, in this analysis. Mm-hmm. So there's no discounting, which is unusual for me, has to be said. But there's no discount, no time. So we haven't taken into account the fact that actually it takes a long time to restore some of these habitats back to something that would bring species back into range, right? So there's that. Then on the ecosystem service side, I think another example that we have for the UK, so the group at LEAP in the UK, they have this amazing spatial optimization model where you can run all sorts of different policy experiments, including thinking about the shadow price of biodiversity. And when you try and understand the costs, it's not just the agricultural opportunity costs like we did here, but it's also like when you change habitat, what are the wider ecosystem services that change also? So like water quality, reducing flood risk, recreational values is a massive one in the UK, right? So all of those things, like if you were to do it properly, you'd do it like that, I think. And I think that's broadly what you were getting at. Is that right?
What I will say is maybe this is a very informative model in a given type of ecosystem. And then we have these areas in the map that there is nothing to say with this model.
Right.
That's what I will ask. I'm more asking than suggesting.
I see bits. Well, they just fall off because they're just too expensive. Yeah, I think it might be part of it as well. Mm-hmm. Yeah. Grand. Any other questions? There's a couple of hands up, which is great.
One back here.
Oh, yeah, there you are.
Wanted to take us back to the conversation around additionality in this map, recognizing that's not what you were thinking about when you were running this model. Uh-huh. but in particular, thinking about the potential versus realized additionality, which I think of as having a bit of a trade-off, where you've got the highest potential additionality, it's perhaps most costly and most difficult to realize it. But trying to think about how that relates to this cost approach to thinking about the value of biodiversity, and how, have you thought about that, the relationship between that and that wedge between potential and realized additionality?
Yes, I wonder, right? So I wonder if there is a trade-off in that way here. So the short answer is that this is a very interesting question, and I don't have an immediate answer to give you on the additionality side. I think like those trade-offs, I mean, I think you've worked on this a fair amount as well, right? So almost certainly is an aspect that we haven't really gotten our heads around. So we're really at the kind of proof of principle stage as we talk to like the UK government about this, saying, look, you don't have a price for biodiversity, consider this. Yeah? So no doubt there's some trade-offs there in terms of like the least cost versus see this is the thing, right? So that's telling you, let me think about this. So that I guess the trade-off comes where you've got like highly costly areas that would need a lot of revenue, but also have this big impact on reducing extinction risk, right? And they're in the curve here somewhere, but we're assuming that they are just as easy to handle as the other ones, and we don't have any texture there at all, I'm afraid. Yeah, but it's absolutely right that we should be thinking about that. Yeah. Was there one other question? Yeah. There's someone down here. Yeah. I have no idea, like, whether we're running over or we're all good, are we? Okay, grand.
Thank you, Ben, for the great presentation. The last part, and particularly the part of Bolivia and Latin America, it's more a methodological question. You say that you use some machine learning methods. Basically, they probably estimate the risk of deforestation based on the past, but there is a layer there on Latin America has like a lot of particular types of land property rights, communal property rights, like tribal property rights, like private property rights. Yeah. That they might be barriers to the implementations to some mechanisms to offset that. I don't know if you have any thought or any idea of how to integrate these kind of features of Latin America into the AI models or the risk of deforestation?
Yeah, it's a good point. Obviously, it's a hugely important issue in terms of like determining outcomes, property rights. So we did, in the very beginning, we did have some property rights data for Bolivia, but we don't have a full mapping of that for Latin America as a whole, right? So for Bolivia, we did introduce some kind of property rights stories. So it's hugely important that we do that, yeah. And I don't know how. At the moment, we don't have any texture which can tell you, right, this kind of property rights structure means this level of risk and so on. We don't have that yet. It's just a pure prediction that we're thinking about, because all we're thinking about is additionality, like where is it and how can we think about potential additionality. The trade-off with the cost side of things as well is very interesting. Of course, in this map here, this is like values. These are dollar values of carbon that you would expect from the social value of offsets type formula there, and they go up to sort of $300 and so on per hectare. And in Bolivia, for instance, the average opportunity cost of land is about 240. So if we were to put that layer on here, that would give us a very different, and like if we had, varied that layer of opportunity cost here, it would have a very different, it would knock out some areas that are very highly potentially additional and would reveal those which are probably realizable. So that's the next step in this project here. Not necessarily to do with property rights, but just bringing those things together there. Yeah. The other thing, just one other thing about this is, you see this map, which Villa will talk a lot about tomorrow. You can sort of see so this is Santa Cruz, agricultural explosion from Santa Cruz from 1985 onwards. And you see this area here becomes a protected area. And it sort of seems to act as a buffer and everything like that. But actually, it wasn't just, even before that, it had a specific set of property rights associated to it. And then it became, on top of it, a layer, a sort of protected area. So it had a different set of rights associated with it. So there's an example of what you're talking about how important the property rights structures could be. Yeah. Any more? Hello? Seems to not be picking you up. Is there a button you have to press on there? Or? Yeah. Habla, habla.
My question was basically, I think like you said, one of the biggest questions that you have about the marginal benefits is that you have multiple ways of valuing nature, because now you're doing extinction, but you mentioned redundancy of a species or complementarity, and depending on the measure that you use, you benefit some area of the country, right? Like, if we think about what benefits agriculture, probably is not to have protected areas close to the border of agriculture and primary forest. But if we think about other sectors of the economy, maybe those are more important. So do you think that at the national level, we would ever be in agreement of what are the marginal benefits that we should use?
Agreement.
So because different measures of marginal benefits will give you different answers of what to protect or what not to protect, or even what is the price of
Yeah. So I guess it's such a difficult question you're asking, actually. It's so right. I guess, like, in general, what we would think about is natural capital, right? We'd stack up all of those benefits and ecosystem services that we get, and we get a measure of, like, an asset value, and that measure of wealth would be the thing that we would be evaluating from a macro perspective, right? Now, a lot of studies on this have shown that natural capital varies from one place to another, but then it's a question, in that context, it's a question of kind of central policies to even out any kind of inequalities that happen in terms of natural capital. And maybe it's about devolution of rights to natural capital and things like that. So I'm beginning to waffle a little bit because your question's so difficult. But that in principle is how I think we should go about it, is building up all of these amazing studies that we've seen on the value of biodiversity. They're kind of just really scratching the surface. But in principle, we would really get to the bottom of all of this and come up with, like, insurance type values for those, like those supposedly redundant species, plus all of the connections to human well-being, ecosystems. You know, we would do this work. And I feel like what I've presented here actually is a bit like what environmental economics was like in the 90s, you know, when we first started thinking about climate change. Oh, okay, yeah, like, let's have a module that has some climate change effect coming into the economy. But what are the damages of climate change? Oh, I don't know. Let's ask 20 experts about this and see what they say. Plug the numbers in, and that's basically how the DICE model started, right? So I'm not saying I'm going to get a Nobel Prize for this stuff, but I feel like you've got to start somewhere, in a way, right? Yeah.
Thank you.
Hi, thank you for the presentation. I just wanted to ask you a question from like not knowing much about this topic. So you mentioned that you use risk of extinction, extinction risk as your preferred measure to get a value of biodiversity. I wanted to ask you, what are the other measures that can be used? Because you said, oh, some other people could use some other ones. What are the other ones? Why do you prefer extinction risk for your estimations? And what are the arguments that you have heard, that you have received in favor of that one and of other measures to value biodiversity?
Yeah, okay. So there's lots of different reasons for choosing extinction risk. In many ways, I want to get back to the equations so that we're on board here. Let's, firstly, right, there was a paper out recently by Burgess, I can't remember the first name, it was in the annual reviews, I think. All the different metrics of biodiversity, 590 of them, right? So this is not the only game in town, it's for sure, right? There's lots of different ways in which you could measure biodiversity. So there's a kind of pragmatic reason for thinking about extinction risk, but there's also a sort of, there's a kind of, maybe there's a technical reason as well. The pragmatic reason is that most people's concern about biodiversity manifests in worries about losing species forever. Right? And you see all of the conservation organizations are really playing on this to drum up money and things. That makes me sound very cynical, but you see what I mean. This seems to be the major concern, so they try and do something about it, and they get money to do that, and conservation writ large happens. So there's that part of it. But then maybe there's a technical reason as well, which is like it's an outcome, right? So extinction risk is an outcome. So you might use like species richness as a measure of biodiversity, often used in sort of applied work to see like the impact of this or that policy on biodiversity. But that really, why would that change at a global level only through extinction, right? So in a way, like extinction risk captures that concern about species richness, right, in many ways. Other measures would be, and you see these are used a lot in finance these days, so like the finance kind of footprinting. I don't know if anyone works in this area, but there's kind of been an explosion of footprinting tools for financial organizations, corporations, portfolio managers, this, that, and the other. They use intactness as a measure, which is, it's a bit like the ratio of current area over original area, but it's actually, you know, what species would have been here versus what species are there. It's a mean species abundance metric, or there's the one that the Natural History Museum pumps out. It's called the Biodiversity Intactness Index. These are used widely for footprinting exercises, and the reason they're used widely is because these people were the first movers on this particular metric, so that you can get global estimates of these particular metrics that can be used to evaluate a portfolio here or corporations' supply chains in different parts of the world and so on. So you'll see that used a lot, and you know, it's fine. It's more of an ecosystem measure, I think, is what people argue there, rather than a biodiversity measure. So my long answer is that I think extinction risk is really the main game in town, but there are many other things that you might be concerned about, and yeah, go and knock yourself out, and you can think about how intactness, the costs of improving intactness work out, and then you end up with a different shadow price. Yeah. Thanks.
Thank you very much, Ben. So now, please don't go. We have an announcement by our president for some practical issues.
Oh, nice. That's very kind. Thank you very much. Thank you, everyone.
This is a really wonderful presentation. By the way, looking at the Colombian map, we are located on the Oriental Cordillera, so now we confirm that we are a step on a very valuable land. Thank you. Some announcement for the rest of the day. We are starting the parallel sessions at 3:30. In the next 10 minutes, please leave the auditorium through this door. And over there, we are going to get to the plaza where we were yesterday, and we want to make the group photograph. So please gather all of us there for a group photograph before the parallel sessions. Between the two blocks of parallel sessions, we have a coffee break. And at the end, remember, we have our gala dinner. Everyone is invited to the dinner, so please join us. When we are ready to go to the dinner, our staff will lead you through the way. It's just 3 blocks from here, so just follow them, but they will be located strategically so you don't get lost. So after that, we can meet at the restaurant, which is actually a very beautiful house, and we hope all of you enjoy. Thank you.
you